Hello, and welcome to the Physics PBL Task 1 summary. In our first PBL task, we were presented with this system and asked 3 questions. The first question asks that how are theta, the angle between the normal line and the rope that the ball is connected to, and the acceleration of the system are related. To find that out, we first have to write all the forces acting on the system. And since there are no friction coming from the pulley and the ground between the ground and M2, we can say that this is the only force acting on the system. So as we know, force is equal to mass times acceleration. And we have just seen that the force acting on the system is m times g, and it is equal to the whole mass of the system times the acceleration of the system. So since we know the mass, which is m1g divided by m1 plus m2, we have to give a look to the ball. The ball's angle is defined by 2 accelerations. First is the gravitational acceleration, and the second is the acceleration of the system. So the ball is accelerating in 2 directions. The fact that we are saying the ball is accelerated away from the system is coming from the system accelerating away from the ball. And from the perspective of the ball, or from the perspective of the system, the ball is accelerating away from it. And we will do a little geometrical trick here. We will take this vector and put it here. Extending this line, we know that this angle is 90 degrees because gravitation is acting only on the y direction, and the acceleration of the system is acting only on the x direction. And if we continue by extending this line, we also see there is a 90-degree angle here. And now it will be a bit cluttered, but we will see that there are 2 triangles here. And these triangles share 2 of their angles. One, the leftmost angle, is shared. Also, they both have a 90-degree angle. So we can conclude that
the angle between G and the rope
also theta. So going back to our initial drawing and drawing another version of that triangle here, and we will call this the vector r, which is the sum of the 2 vectors. The angle here is theta. So we can conclude that the tan of eta, the tan of m1g and m1, so we can conclude that the ratio of A and G, which is opposite to adjacent in the given graph, is in fact tan theta. Another way to write this, the arctan of A divided by G equals theta. And another and the final way to write this is arctan. We will take this multiplication of A times 1 over G and imagine that we are multiplying it with this. M1 divided by plus 2. So the arctan of M1 divided by M1 plus M2 gives us theta. So using this, we can move on to question 2. We will just plug in the numbers. Arctan 250 divided by 1500. And this gives us theta. Let's do a quick calculation with the alpha power calculator. Arctan 250 divided by 1500. And this gives us the result of theta equals 0 pi, or theta equals 9.46 degrees. This makes it seem like it's wrong, so we will mark it like this. Perfect. And our last question, the largest theta value possible. Since we see that the theta equals arctan m1 or m2, m1 plus m2 For the third question, we should take into consideration of how our system works. The stronger the first mass pulls, the higher of an angle we are going to get for theta. Here we have the graph of arctan x. And what we call x is actually m1 divided by m1 plus m2. So let's do a little thought experiment as m1 or m2 reaches infinity, and then write it as mathematical expressions. Limit as x goes to infinity of x divided by x plus c, which is a constant, and this equals in fact 1, as the both coefficients here are 1, the powers of x is also 1, and as this expression goes to infinity, we can just neglect c. And let's do the same for another limit. So this one shows us what will happen if m1 reaches infinity. And the answer is it would only reach an angle of 45 degrees. Because arctan 1 equals 45 degrees. Pi divided by 4. Let's have an angular limit where x goes to infinity, c divided by c plus x. And let me correct this one. It's not x goes to infinity, it's x goes to 0. The answer is still 1. If we just put 0 where we have the x, we would get c over c, and which is again 1. So again, arctan 1 equals 45 degrees. So the largest angle we can get here is 45 degrees for this system.